Hey folks, before we get into electromagnets today, I just want to look at a couple more of these magnetic fields due to current type things. We're just going to do the first one in each number here. So the first, number 15, we're just going to draw an X or a dot in these circles for the magnetic field produced by this current that's shown there. So the current is going towards the top of the page. So we put our thumb towards the top of the page and wrap our fingers, right? So my pen goes towards the top. So does my thumb, and I'm going to wrap. So on the left-hand side of my thing, as I'm looking at it, because you've got to look at it as you're pointing towards the top of your page. The left-hand side, my fingers are coming out of the page to this side. Should be a dot. And then the other side, because it's going to complete a circle, it's going to be an X. They're always going to be opposites. Okay, for this one, for 16, we're just going to go straight down to the first one of each of these. For the following currents, indicate the magnetic field's direction at the star. Well, at the star here, so again, my thumb's going to be pointing downwards. So my pen's going to point down or towards the bottom of the page. And so it looks like my fingers are pointing this one. Actually, I do want to look at this one over here. Over here onto the right-hand side. I'll put a star over by here. Okay, so we know here the X, this is my wire, and my X indicates that my thumb would be going down into the page. Right, so it looks like my field is going to circle like this. And I look down on it, that would be in a clockwise sense. But I only want to find the field direction at the star. So when we think about the circle that goes around here, the circle is going to be kind of like, I didn't mean to do that. Let's see, the circle is going to become like this. Let's see if I can draw it like this. It's going to come around like this, and it's going to be just a big circle all around. So at this point right here, the magnetic field will actually be pointing upwards, but it's all going to be part of a big circle that goes around. And then let's do number 17 here. The first one, follow. Now this tells me this is the magnetic field. By the way, the symbol for the magnetic field is the letter B. You're going to learn that soon. And then the current, this is my wire. So we want to know the direction of the current in the wire. So the magnetic field here is into the page. So you know my thumb's either going to be pointed towards the bottom of the page or towards the top of the page. Which one are my fingers pointing into the page at the X? And that would be when my thumb is pointing towards the bottom of the page. So the current would be acted downwards. All right, so let's move along here. Okay, we're going to talk about electromagnets now. Okay, how does this stuff relate to electromagnets? So as you saw in the little demonstration, the electromagnets are just loops of wire with current running through it, and they act like a magnet. And the nice thing about them is that you can turn them on and off. Okay, so solenoid are just wires coiled in type loops, and they act as an electromagnet. Okay, so if you remember, if I have a straight wire, the magnetic field acts perpendicular to the direction of current. So if right, so we see a picture here. I'm just going to go ahead and get rid of this right there and move this kind of out of the way. I'm going to move this up here. Okay, we see that for a single loop that, if I loop my current, you notice how the magnetic field is always pointing in the same direction, always kind of through the loop. So if I loop them all together, the magnetic field actually turns into something that looks very much like a regular magnet, right? And so take a second just to kind of make a sketch of this. It doesn't have to be a great sketch, but just an indication that these loops create a magnetic field that are very similar. And so when you loop a bunch of wires together in a solenoid and you run a current through it, the magnetic fields line up to be just like a magnet, and it becomes a magnet. Right? It's a magnet that's controlled by electricity. And the best part about it is that when I disconnect the battery, it stops being a magnet. You can turn it off and you can turn it back on. Right? Hopefully, if we're able to get all the equipment done, we're going to have everyone build one towards the end of this unit. So I will put a link later on of a video demonstrating this too, so you can see that, so you can see kind of how the electromagnet works as well. And you're going to watch a video tomorrow on how the electromagnets are used in some of the Disney parks. Okay, so I want you to think about the lab we did yesterday. How do we strengthen the electromagnet? And what were the different things that we could do to make that electromagnet stronger? Okay, so what were some of the things that you could do? What happened to the current? Did you make the current bigger or smaller? Okay. We increase the current, we can increase the voltage, and we can increase this time, the number of loops. The more loops you have, the better it is. More current, the more voltage, the stronger it's going to be. Okay, and the other thing you can do is if you can wrap the loops around something that can already be magnetic, like iron or steel, it will become even stronger, much stronger. And that's when you wrap it around an iron core or a steel core, it becomes a true electromagnet. Right? But again, the benefits of this is that you can turn them on and off. Think about in a junkyard when you see those pictures, those big. Here, let me bring this up so y'all can see me again. You know, we bring those big electromagnets and they'll go down and they'll grab the car and they turn on the magnet and they're able to lift the car up and then move it. And then when they're done with it, they turn off the magnet, it drops, and the car falls. So it's very useful for that. All right, so next couple of days, I'm gonna have you all watch some kind of general videos. I will not be here Thursday and Friday, nor will I be here Monday. But Thursday and Friday, you're gonna watch. Thursday, you're gonna watch a video of how electromagnetism appears in Disney parks. Then you'll watch another video on Friday, and then Monday we're gonna start talking about how these these magnetic forces or these magnetic fields can cause forces between each other. And so we'll spend some time on that, and then I'll be back on Tuesday, and we'll continue on with the unit. All right, so y'all have a great day.